All right. This was our first AC lesson. Again, we're trying to find a voltage or a current on a curve. An instantaneous voltage or an instantaneous current on a curve. So if we're given beta, the length or velocity, can we find Emax? Yes, right? Just multiply those three together, gives you Emax, right? If you're given Emax and you're given beta and the length, can we find the velocity? Just algebra, right? Okay. All right, know the left-hand rule for generators. I like using did everybody write down the one that the first thumb, second, everybody write that down? All right, that's the way I remember it. And we trace the instantaneous voltage and current by multiplying E sine or Emax times the sine of whatever angle. Okay. So if I say that the period, big T, equals 100 microseconds, what is the frequency? Frequency is 1 over T, yes?
Yes, sir.
All right. km measured in hertz. All right. So how many degrees would I have rotated at 50 microseconds? I got 100 microseconds complete rotation. 180. Okay. So at 50 microseconds, I will have rotated 180 degrees. Okay, and we find this by angle theta over 360 equals T over period. Okay. What did I say, 50 microseconds over 100 microseconds? Okay, so I wind up with 0.5 here. Multiply both sides by 360. So know what period is, know what, if we ask you for how much rotation the signal is, how much the signal is rotated at a certain time, be able to tell us in degrees what that time is, or what that angle is. All right, this is in your formula sheet, right? Or I think it says T equals 1 over F. Same? Okay. And this is what I just did on the board. All right. Radians to degrees. How many degrees are in radians? How many radians are in degrees? This one's really, really easy just using your calculator. Right. So you may see something like, I don't know, 3 radians equals how many degrees? That's a given, right? So if you calculate 2 radians, type 3, DRG to your degree mode, voila, there's your answer. Okay. Okay. Angular velocity times time. Okay, this another way of figuring out, or another measurement of finding out the phase of an angle, or how far it's rotated and how fast it's going. Okay, to find your instantaneous current and your instantaneous voltage. Is everybody okay with these right here? Omega t plus or minus angle theta. Yes? Okay, this is on tape, right? All right. Making sure. Okay. Here's the degree to radians calculations or conversions. You can do all this or put it in a calculator. That's what I recommend. That's a gimme. All right. So if you're given everything here except one value, you're given instantaneous voltage, you're given Emax, and the sine and angular velocity, okay, which is that omega, find time. Okay, well, if you're given everything except the plus or minus the angle, find the angle. Is everybody okay doing that? Okay. Converting between voltages, this is really important. You've got to know the half-watt chart. Okay, I always start at peak. Okay, I always go to peak. Okay, because then I only have to remember two things. I know peak to peak is 2 times peak. That's easy. Yes? But RMS is 0.707 and average is 0.637. Those are the only 2 numbers that I have to remember. Everything else is easy. Okay? I can go from peak to RMS, peak to peak, or RMS to average. If I just reference my peak values, come back to peak, and then go from there, go to where I need to go. Okay, does everybody understand? Does anybody want an example? You guys are on tape, so I don't want to hear tomorrow that you didn't give me an example. All right. So, note this is not on your formula sheet, right? It is not, or it is? It is not. But I would remember this if I were you. If these two right here, from the peak to RMS and average, and effective and RMS are synonymous, it's the same thing. Okay? If you know those two, you can get everywhere else. All right? Same rules apply here as they did in DC. If you're going to put something in shunt, the value stays the same. Okay, you're switching from a voltage generator to a current generator. The arrow, where the direction it's pointing is less important because this is an AC, right? Current is going in both directions, right? So the arrow really doesn't matter, but this does. All right, the value of the impedance. Any questions?